Okay, today we're going to talk about 9-6, analyzing solutions to quadratic equations. If you remember over the last couple sections, we talked about projectiles, when they fall to the ground, how they reach the maximum height. In 9-5, we talked about the quadratic formula, which is x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that quadratic formula gave us two solutions, or in some cases, maybe even one solution, depending on the problem that we had. But that was a way to do it by hand in order to find our two solutions. And so what we're going to talk about today is, without even doing your quadratic formula, you're going to be able to determine whether the equation has 0, 1, or 2 real solutions. Now, how are you going to do that? Well, it all comes from the value of the discriminant. The discriminant is b squared minus 4ac. Well, where does b squared minus 4ac come from? Well, all that comes from is from underneath your square root sign. So that little equation right there tells me if I have two solutions, if I have one solution, or if I have 0 solutions. Let's go ahead and dive into this. Using a graph or table to determine solutions to a quadratic equation. Example 1 says, consider the situation of the LaQuinta diver. Graph and generate a table of the parabola with the equation y equals a negative x squared plus 2x plus 27 to determine whether the diver will ever reach 27.75 meters, 28 meters, or 30 meters. Well, I already put a graph on here for you, but as you can see, they use their x minimum as 0, their x max at 7, their y minimum is 0, their y max is 32. So what you could do is on your calculator, you could do the same thing. You can type this equation into your y1. Let's go ahead and do that. That way I can show you. So y equals negative x squared plus 2x plus 27. And since you know this is your y-intercept, 27, you should already knew that your y-max needed to be greater than 27. So 0, 7, I'm just going to give you the picture like I got right over here. And 0, 32. If I hit graph, there's my equation, okay? Now, A says they want to know when it equals 27.75 meters. So, if I go here to my y equals, and I'm going to put my y2 as 27.75 meters. Okay? Hit graph. Okay? And as you can see, my graph is a little bit harder to see than what the book's graph is. Okay? Maybe if we go down a little bit to maybe 0.5 as my scale, maybe that will help me out. Nope. But if you go over here and you look at this graph, their graph right here is at 27.75. Okay? And as you can see here, it crosses its path once and twice. So 2 times it will hit 27.75 meters. The next question says, when will it hit 28 meters? Well, if I draw a line right here at 28, as you can see, it gets up to 28 only once. It gets up to 28 and then it starts coming back down. So at 28 meters, it is only going to go one time. 30 meters is up here. How many times does it hit 30 meters? Well, it never gets to 30 meters. So 0 times is your answer. Okay? So it touched 27.75 meters twice, 28 meters once, and 30 meters 0 times. Okay? Now, since my graph was so bad, what I probably would have done was I probably would have not looked at this part down here because I really want to focus on up here. So what I probably would have done was shrink my window. So maybe make this, maybe even, 3, maybe even 5. Oops, I changed the wrong one. 0. And maybe bring this up to 16. Maybe make this 0.5. Okay. So you can look at it a little bit better. And as you can see, I'm going to have to dive into it a little bit more, get closer and closer. Make it 30. And I could go up by 0.1 maybe, 0.2. That's going to generate my graph. What's going to happen is that's going to get closer and closer to where I'm going to be able to see it more clearly. And I don't know, there's something wrong with my calculator at this point. So we'll just move on so I'm not wasting time here. Okay? But as you can see, by looking at your graph, you can tell how many times it touches each one. But in our discriminant property, when you have your equation in standard form, ax squared plus bx plus c equals 0, a, b, and c are real numbers. A cannot equal 0 because otherwise then we don't have a quadratic formula. But if our discriminant is greater than 0, that means 2, 3, some positive number, you will have exactly 2 real solutions. If our discriminant equals 0, then you have exactly 1 solution. And if our discriminant is less than 0, that means you have negative numbers. -1, -2, so on and so forth, -163, okay? Then your equation has no real solutions. We call those imaginary numbers. Because what happens in our quadratic equation is, if you have a square root of some negative number, you cannot actually find the square root of that. Actually, the square root of that is a 10i. I meaning imaginary. But we'll talk about that at a later time. Okay? So, if it's greater than 0, 2 real solutions, equals 0, 1 real solution, and less than 0, no real solutions. Now, where are you getting your B, A, and C from? Well, just like you did for your quadratic formula, right up here. A is a number, B is a number, C is a number. You just have to make sure that it equals 0. So let's move along. Here are different types of functions, okay? If you look here, my A is 1, my B is 1, my C is a -6. So they put 1 in for B. They put 1 in for A. They put a -6 in for C. They did the math. 1 squared minus 4 times 1 times a -6. A negative times a positive times a negative gives you a plus. So it's 1 plus 24, which is going to give you 25. Okay? 25 is positive. So your number of x-intercepts are 2. That's how many solutions you have. Which means if you went ahead and graphed this function, you're going to look for 2 solutions. One right here, one right here. This next one here, my A is 1 again, my B is a -6, my C is 9. Okay, A, B, C. Put a -6 in there, it's 36. Minus 4 times 1 times 9. Well, -4 times 1 times 9 is a -36. 36 minus 36 is 0. If you have 0, then you have 1 real solution, which means it's coming down to our x-intercept and only touching at 1 point. This next one, A is 1, B is 2, C is 7. Put 2 in for B. 2 squared is 4, minus a -4 times 1 times 7. A -4 times 1 times 7 is a -20. Sorry. Is a -28. 4 minus 28 is a -24. Okay. -24 is negative. So you have 0 solutions, 0 x-intercepts, which means there's going to be a graph. It's just not going to cross our x-axis. So you only have solutions when it crosses the x-axis. We should all know that. Okay? Moving on. Let's do it without using our graphs. That's what this is all about. Quiz yourself. Determine the number of real solutions to 6x squared plus 3x is equal to a -7. Well, we don't want that to say equal to a -7. We want that to say equals 0. So the first thing I have to do is add 7 to both sides. Okay? So it's going to give me 6x squared plus 3x is plus 7 is equal to 0. All I did was take that -7, move it to the other side. Now I can find my A, B, and C. My A is a +6. My B is a +3. My C is a +7. Put it into my equation. B squared minus 4AC is my equation. B is 3, so it's 3 squared minus 4 times A is 6 and times C is 7. Now, why did I put parentheses here? Well, because a lot of you want to just type this equation in all at the same time. If you don't put a parenthesis here and you have a negative number, you're going to get out a negative number, which in turn is going to turn your whole problem wrong. Okay? Please go step by step, people. This math should be easy to do. Okay? You don't need a calculator to do every single step. 3 squared is 9. Minus 4 times 6 times 7. Well, 7 times 6 is 42. Times another 4 is 8, 16, 168. Well, 9 minus 168 is a negative. Anybody? Okay. 159. Okay. This number is negative. So how many solutions do we have? Since it's negative, there are no real solutions. Okay? Since it's negative, there is no real solutions. Let's look at example 3. Okay? How many times does the graph of y equals 2x squared plus 16x plus 32 intersect the x-axis? Okay? Same question. How many numbers of real solutions does it have? How many times does it intersect the x-axis? Those two questions are the same thing. So we just got to make sure this is equal to 0. Well, everything is off to the right, so I just say 0 equals. Okay? And I'm able to find everything. So, what's my A in this case? My A is 2. My B in this case is 16. My C in this case is 32. B squared minus 4AC. That's our discriminant. Well, 16 squared minus 4 times A is 2 times C is 32. Okay? Some of you might be panicking. Remember I said put a parenthesis around this. Okay? Go to your calculator. And 16 squared is 256 minus, and 4 times 2 is 8. Well, we got a negative times a positive times a positive. We know it's negative then. So 8 times 32, because I can do 4 times 2 in my head, is also 256. Well, 256 minus 256 is 0. Since this is 0, I know that there is one solution. Okay? That's all I have for you today. Those charts that I gave you on what b squared minus 4ac equals, positive 2 solutions, equals 0, 1 solution, negative, no real solutions, you need to memorize those. Okay? We'll have a quiz on it at a later date. Thank you very much, and I'll see you tomorrow.